Hello, welcome to Algebra 1, Semester 2, Unit 10, Final Exam Study Guide. Let's get right into this. Remember, this is just an overview of how the questions might be asked. There might be quite a bit of variation on your final exam, but I want you to start taking the material that you've learned and really using it. Mostly this is to kind of help you with the test-taking skills, the test-taking just ability to look at answers and reason. The actual materials you should know from the unit studies. Go back through those videos, check online, search out some of this stuff. Your knowledge is for you to gain. You've got to pursue it. So you go after it. I know that you can do it. I've seen you do well in some of these things in class. So number 35, very first one on Unit 10. Which of the following best describes the data in the table? Well, we should always look at the y value and look at it like a sequence and see how can we get from one to the next. Now we have looked at a lot of series. We've looked at linear, quadratic, and exponential. So right here you should be immediately thinking, are we multiplying? Are we adding? Are we going to go to a second level? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. We hit right upon it. It has to be, because it's a multiplication factor, a ratio, it has to be an exponential growth. Growth because that's larger than 1, and exponential because you're multiplying from one to the next. Next problem. Since the year 2001, and again I encourage you to pause the video and rewind and take your time. I'm just pushing through to shorten the time that it takes to upload this. Since the year 2001, the population community A grows exponentially as illustrated in the table. The exponential rate of growth is 1.3. What are the units of rate of growth in the table? Well, they're just asking for the units, guys. And when we talk about units, we always talk about units per time. Miles per hour, numbers per year. Yeah, it's always about time. So the other thing that you want to look at is it's the dependent depending on the independent. And your independent is always your x. Okay? X is your year up here. We're looking at the year, that determines the people. It's not that the people determine the year. So it's always units per time, people per year. Okay, next one. Determine which is growth and decay. Ooh, back from our notes. A, B to the X. B value is growth if it's larger than 1. That's growth. If it's smaller than 1, greater than 0 obviously, then it's decay. Okay? So we just need to simplify these. 1.5 to the negative x. Oops. We don't want a negative. So let's make that a positive. It would be 1 over 1.5 to the x. If you divide 1 divided by 1.5, or 1 divided by 1.5, another way to look at that I think of it actually is I multiply both by 2, so it's 2 divided by 3. You would come out with about 0.67 to the x. That is less than 1. That's got to be a decay. Immediately I go to my answers. Number 1's growth. I know that one's out. Oops, I meant to mark that out and circle that said growth. Decay, that could be it. Decay, that could be it. Growth, nope, that one's out. So we're down to 50-50 shot at getting this right. Okay, this one, at 0.8 is decay. Smaller than 1. This says number 2 is growth, so that means that one's out. This is decay. These are right. Now let's just double check to make sure that these are correct. This is a negative exponent, so we need to flip it to the other side to make it a positive exponent, 0.5x. Well, this is a complex fraction. You shouldn't ever have 1 over 1/2 and leave it that way. So we take 1 divided by 1/2, which is the same thing as 1 times 2 over 1. So our factor is 2 to the x. That is definitely a growth. Okay? With that said, unless you just have lots of extra time, it's not a time test, you could stop at that point. This one is obviously growth. Okay? Okay. Next page. Number 38. Now, again, we're looking at a, b to the x. This is our starting value, or our 0th term. Do not forget, 0th term means that it's intersecting the y-axis. So these are intersecting the y-axis at the same spot. Now, is their growth rate different? Absolutely. This one is only gaining by a factor of 2 as it goes to each slot to the right. This one's gaining by a factor of 4. So it says compare the functions. I think we've already kind of compared them. The x-intercept, well, we probably aren't going to have an x-intercept on exponential functions. Don't forget, they're the ones that like to have an asymptote and stay away from whatever that asymptote might be. And since they aren't shifted by a k, they aren't going to touch the x-axis. Y-intercept of f of x is greater. Oh, we just said the y-intercepts are the same. That would make that wrong. The functions increase at the same rate. No, they increase at this one twice the rate of that one. So that one's out. Because of that same rate. The functions have the same y-intercept. There we go. That's the one that we like. Okay. What is the solution for 4 to the x equals 64? The whole challenge here is to bring that 64 into being a factor of 4. 4 to the x equals, you should have memorized this, it's 4 to the 3rd. That was assigned in Unit 7, so make sure that you go back and review those if that was just rusty. So we can see there that x is equal to 3. What is the possible solution? Again, guys, when you're solving for exponents, switch this into the base of the other half. So 2x minus 9 equals 5 to the 3rd. Now, we don't need to keep the same bases in the equation. We can set our exponents equal. 2x minus 9 equals 3. Add 9 to each side. 2x equals 12. Divide by 2, x equals 6. Don't you like being able to do that with a problem and not have it look so difficult? You don't need to mark these others if you've shown this work. I can see that you know what you're doing. Okay, what is the solution of the system? Excuse me. Graphed. Well, solution and system are key words here. System means 2 or more functions. Make sure you look at this graph correctly. This is your x-axis here. This is your y. They're not the graphed lines. The graphed lines is this curved line and this line right here. A solution is the point of intersection. It's this easy, guys. Give me that point right there. Should be 2, positive 4. Okay? Next problem. Next problem's almost like the previous problems, where we are simply giving them the same base. So we have y equals 8 and y equals 2 to the x, and it says solve for x. Well, if we know y is equal to each of these, y is equal to itself, so we can take 2 to the x is equal to 8. 2 to the x is equal to 2 to the 3rd. Okay, next problem. Ooh, I can barely fit this one on there. Which of the following represents this? Okay, this is an HK format. So we have A times B to the X minus H plus K. Remember, our K is a shift up or down, and it goes exactly as it says. So normally, oh, I'm so sorry, I didn't realize I was off. So normally, this K, again, it's AB to the X minus H plus K. That could be a plus or minus out there. This K is always, plus K is up, minus K is down. So we've got to shift down 5. Our typical parent function crosses right at 1. If you remember right, it crosses like this on the graph. So we're looking for it to shift down 5 from that 1. Look around the graphs. You should be able to see which one shifted down 5. If you spotted this one, you're correct. That is the correct answer. Now I want the correct formulas for the ones that are graphed there, though. This one, as you notice, is shifted up 5. So I would hope that you would write this function 3 times 2 to the X plus 5. Now this one is moving the graph five to the, not quite 5 to the right, but I would at least expect you to tell me, hey, this one has an increase of a H value, or it goes to the right H amount, put at least a minus H value there. And this one goes to the left, so it would be 3 times 2 to the X plus H. Remember, the H's are always backwards, or opposite, I should say, of what they seem like they would be. Write a recursive formula for the sequence, first term of the sequence. You should know your recursive formula. F1 means first term. Look right here. Which of those is identifying the first term? Get rid of the ones that are not. That means this goes, all based upon that. Now from there on, you need to know the rest of the formula, and that is f of n equals fn minus 1 times your common ratio. Well, what's our common ratio? 3 times what gives you negative 6? Negative 2. Negative 6 times negative 2 is 12, and so on. So the negative 2 would be our common ratio. This one, we do not need. It's off because of that negative 9 there. Okay, write an explicit formula for the geometric sequence. This one can be a little bit tricky. They're giving you the 3rd term and the 5th term. Don't be scared by that. Here's our 1st, 2nd, 3rd term is 1. 4th term, 5th term is 0.25. Okay, well, if we think about it, we'd have to multiply by the common ratio, multiply by the common ratio again, and we get our 0.25. Just put that into an equation. 1 times r squared equals 0.25. You can divide by 1 if you feel the need to, otherwise you can just say r squared equals 0.25. Find what r is, take the square root. Take the square root. R equals 0.5. Okay? Now, we can plug this in here, and we take 0.5 times 1 would be a half of that, or 50 cents. I always convert to money when it's a little bit challenging. You've known money forever. Now, half of 50 cents is 25 cents. So going the other way, half of 2 would be 1. Half of 4 would be 2. So our beginning factor, if we go back to the A, b to the x. This is our starting, our 0 point. Actually, in a sequence, it would be our first factor, and then we'd have x minus 1 or n minus 1. Remember, we equated all of these formulas on the board. So look for your first term, and the only one that they show it is right there. All the rest of these are off, so that's your answer. Okay, that's it for Unit 10. Thanks so much.